If you're just logging in, we're giving everyone another second to join. Hi, everyone. Welcome. My name is Maria Nava. I use she, her pronouns, and I'm one of the admissions counselors here at the college. I'm also Middlebury College class of 2018. As always, our Wednesday webinars focus on a particular topic, and we welcome your questions today on STEM at Middlebury. I'm very excited to be moderating this panel as a former math major. We have a wonderful group of panelists that are here to share valuable information with you. I do want to take a second to acknowledge that COVID-19 has drastically changed our college search process, so we appreciate you taking the time to be here with us today, even if it is virtually. Before we jump in, I also want to remind you to type your questions in the Q&A box throughout the presentation. We have some folks behind the scenes that will be typing answers to the questions that we may not be able to answer live. We do have a big audience today, so we will try to get to as many questions as we can in our short time together. Now I will hand it over to Rick to tell us a little bit more about what STEM looks like at liberal arts schools. Take it away.
Thanks, Maria. Good evening, everyone, or good morning or good afternoon, wherever you may happen to be in the world these days. I'm Rick Bunt. I'm a professor of chemistry and biochemistry here at Middlebury. I've been here for 22 years now, which seems like probably like a lifetime and a half for some of you. Seems like that for me too at times. To give you sort of a brief overview, the thing I wanted to say most about STEM at Middlebury is that STEM and our STEM students, who you can see here as well, we really are a part of the liberal arts. We really think that science and engineering and mathematics and technology are key liberal arts components. And so we don't see ourselves as separate from or added on to a liberal arts education. Right? A liberal arts education at Middlebury is a great education for everyone, including all our STEM students. Even history students too get pretty good educations, I think. And I would point out that our STEM students are among, I think, the most liberally educated students at the college. We take almost half our classes, or if not more, outside of our major. And so we do take the history and the English and the religion and the political science and all the other fun classes that are out there. In fact, one of the hardest parts is choosing only 36 classes, right? Because they're all so wonderful that it's really hard to just take the small set that you might get. And so everyone is important, and that's fantastic. In terms of the class sizes you might expect, the classes in the STEM fields tend to be a range. We have some larger classes. We want to get every student who we can into the courses. And so an introductory course at the 100 level might have 40, 50, or 60, or sometimes more students in the main class. But that's almost always paired along with smaller discussion sections and or also laboratory sections where you're meeting, again, the faculty individually in those smaller settings. So you get a chance to know people much more closely, though not too close these days, but in general, pretty close interactions with faculty and students in that regard. The upper level classes do tend to get, again, smaller and more specialized. Class sizes might be on the order of 10 to 15 students. Sometimes 3 or 4 students are in an advanced course if it's a very specialized course. And so those really do foster those kind of interactions that last a lifetime. Other kind of thing that I think is important about STEM at Middlebury and other schools like Middlebury, to be fair, is that teaching and research really go hand in hand. We don't do them separate from each other. The faculty are all involved in research or scholarship in more general terms, and that scholarship and research is what helps inform our teaching, and our students participate with us in that research quite often. And Professor Spadafora will say more about that in a few minutes. But the biggest thing I would say about the facilities, the equipment, all the resources we have at Middlebury is that they're all devoted toward this mission of education, which again, teaching and teaching through research both involve. So students in geology can use the new electron microscope in their courses and in their research. Students in chemistry can use one of our newer NMR spectrometers in their second year organic chemistry class. It's the same kind of instrument, because I just helped buy it this summer, that you might find at Harvard or MIT or Pfizer or wherever. Right? We really do have the kind of facilities there that allow our students and our faculty to do their very best. And that's really exciting and interesting. Other thing that I'll say just to finish off here is, you haven't even gotten to college yet, and I'm going to suggest where do students go after college, right? And our students tend to go all kinds of great places. They may go to graduate schools, Berkeley, Princeton, Yale. They may go to medical school or law school. They may even, if there are any parents out there, they may even get jobs, some of them, after graduation, or get a job before going back to medical school or graduate school. And our STEM students do all kinds of wonderful things. I thought I would highlight one former student from about maybe 10 or 15 years ago now. Anne DeWitt was a joint major between chemistry and English, and she graduated second in her class as salutatorian and won the Phi Beta Kappa Prize. She decided to go on to graduate school in English at Yale, and she's now English professor. So you can see all kinds of things that come from STEM. That's what's really exciting. So I'll pause now and turn it over to Grace Spadafora to talk more about research and graduate school and medical schools.
Thank you, Rick. My name is Grace Spadafora. I'm a microbial geneticist at Middlebury College, and I've been asked to speak to represent the undergraduate course curriculum in STEM and the kinds of research opportunities that present themselves in STEM. Of course, I'm speaking to you as a woman in science. Actually, women are quite well represented in the sciences at Middlebury. So I want to echo something that Rick said, and that is that many of the faculty, if not all of us, are very dedicated to integrating their teaching curricula with their research agendas. The two are very closely integrated, and there's a clear reason for this. I think we are better teachers because we are active researchers, and I think our research certainly benefits from our teaching experiences and collaborations with students. So the two just naturally go hand in hand. And I can speak for myself when I say that I design my courses specifically as a means to engage students in producing original research of their own. So being a microbial geneticist, I teach courses in microbiology and genetics. That only makes sense. And the labs that are associated with those courses actually engage my actual research interests that are supported by the NIH. So you're doing real research in the context of a course. You can also extend that research experience for course credit by doing independent research under the guise of a faculty mentor. So some of the other courses that I teach as a microbial geneticist include immunology, a seminar course called Mechanisms of Microbial Pathogenesis, and I also teach an introductory course called Cells and Genetics. So for any of you who may come to Middlebury and explore the STEM initiative here, you'll probably be part of this gateway course to the natural sciences, and that is Cells and Genetics. So I may very well get to meet you in person. I certainly hope so. Let's see. Many of us teach science from the primary literature. We like to get our students pretty early on in the curriculum familiar with approaching research articles in the primary literature. We often supplement this with readings from a more conventional textbook, but we are really excited to help you bring what you're learning alive by bringing it into the here and now and connecting you with what's going on in the literature. As Rick mentioned, courses can have a range of sizes. Introductory level courses have a tendency to be a little bit larger. As you become more specialized and climb up through the curriculum, the courses become more specialized and smaller. But even the larger courses are often associated with discussion sections, and I'm always a huge advocate for meeting in smaller groups so that I get to know my students. A little bit about my research agenda, although I only speak for my own. There are many opportunities available for students to pursue independent work if they want to. Some of my colleagues work with the effects of BPA on reproductive fitness. There are labs engaged in studying Lyme disease, in cancer genetics in a mouse model. The work that I'm engaged in is relevant to oral health, which I like to think of as the gateway to general health. And it's funded by the NIH, NIDCR. So specifically, I work with a group of organisms that are among the 700 different types of bacteria that live in the human mouth, and they're called the oral streptococci. And as a geneticist, I use DNA, RNA, and protein approaches to understand how those organisms survive in the transient conditions of the human mouth, both during meal times and between meal times, and what it is about the human oral microbiome that makes it a healthy microbiome, and then what are the conditions that shift or tip that balance towards a dysbiotic microbiome that can lead to disease. Students who work in my lab have authored or co-authored manuscripts for publication. In a time that we don't find ourselves in a pandemic, they've traveled to and delivered presentations at regional, national, and even international meetings. They're very successful in landing research jobs when they graduate. And we have a very high rate of getting students into pre-professional schools, of many of which are of their choosing. I can't tell you how many times I get emails from students who have graduated thanking the Middlebury faculty for pushing them to like beyond, to fulfill their potential and pushing them outside of their comfort zone, because when they pursue pre-professional school, be it veterinary school, dental school, medical school, graduate school, they feel very well prepared in those environments and are very successful. I think I'll stop there and leave the rest for Q&A.
Hello, my name is Mauricio and I'm a junior here at Mid. I'm a molecular biology biochem and math double major. And I kind of want to share with you guys kind of a little bit about like how STEM could be very interdisciplinary. So MBBC is a very interdisciplinary major because you're required to like take courses across many different kind of departments that include math and biology, chemistry, comp sci even. And I think that what that does is it really allows students to kind of experiment, get exposure to just different ways of learning and just getting their hands kind of dirty and dipped into like different like places. A lot of what I enjoy about my major is that it teaches you a lot about just like critical thinking and problem solving. And I don't know, I'm just really grateful that I kind of had a advisor who kind of led me on this path, because it wasn't until last semester when I was taking like another math course to fulfill like one of my requirements for MBB where I realized, oh, hey, I kind of like math as well. So because of that, like I've taken some additional math courses since then. And that's kind of what's really nice about just pursuing something within STEM at a liberal arts college, is that you really have a lot of flexibility and you can just take courses across many different departments and just really figure out what it is that you want to do. Because even within STEM itself, there's so many things that you can do. Yeah.
Hi everyone, my name is Diana. I'm a senior majoring in computer science with a minor in Japanese. And the reason why I majored in computer science, well, that was sort of a weird journey for me, because when I first got admitted into Middlebury, I made it my goal to avoid anything STEM related. But the funny thing was I ended up taking a first year seminar class called Computer Music Programming. And I was just there for like the music component because I have a very creative side as well. But at the end of the course, I found it very interesting how technology can be applied to a lot of different areas and disciplines. And so I was really interested in that. And I started taking computer science courses and I ended up majoring in them. Outside of STEM, I'm involved in two major organizations. The first one is called Women in CS. Basically, our goal is to build a more inclusive community for women majoring in CS and provide them with networking opportunities as well as job opportunities as well, and just try to give them advice navigating through the CS major. The second organization I'm really involved in is Evolution Dance Crew. Maria was actually a president before, and she was the one that introduced me to the crew. And so, as I said before, I have a very creative side, so I like exploring that as well. Even though I am a CS major and it seems like I might be taking so many CS courses, I actually like to balance out my STEM classes with more creative non-STEM liberal classes. So I have taken dance before, I've taken digital art studio before. So I really think the beauty of a liberal arts education is that you can have a balance between all these different areas of interest that you have as a student.
So, hi everyone, my name is Brenda. I use she, her, hers pronouns. I'm a junior and neuroscience major. So I'm going to be talking more about UR STEM and our organization here at Middlebury. So UR STEM stands for Underrepresented in STEM, and our mission is basically to normalize the participation of underrepresented students in STEM classes and careers to bridge the academic gap of students from different backgrounds and improve the attainment of underrepresented students in these STEM fields. So we do this by providing students with mentorship opportunities. So we have two different types of mentorship opportunities. One where we pair underclassmen with upperclassmen, and one where we pair students with STEM faculty and staff. And we also help our members by increasing access to different academic resources and by introducing them to professional connections. And so some examples of past events that we've had are the annual faculty, staff, and student mixer. So this is an event where we bring together students and faculty and staff from the STEM departments in a more casual setting and have conversations about how professors and departments can create a more inclusive environment for underrepresented students. And it creates a space for students to share their experiences and meet professors from other departments. We also have a Meet Your Professor series, which are small sessions where students who have registered for their courses already can meet their professors before the start of the spring semester. And some professors usually go over their planned syllabus or over expectations for their courses. And we believe this is a great opportunity for students to start building relationships with their professors. And we hope that it reduces the stress that may come with going to office hours for the first time. And we also have a UR STEM tutoring program, which is something that we started last semester, where UR STEM members can request other UR STEM members to tutor them. And hopefully we hope that this makes students more comfortable reaching out for help. And this is a way for our members to build friendships with each other within the organization. So that's all I had to say for UR STEM, and I'll pass it over to Tyler.
Nice, thanks. Hi, everybody. My name's Tyler. I use he, him pronouns. I am a senior environmental studies and geology joint major with a minor in math. Yeah, just talking a little bit about my journey in STEM. I'm really excited to incorporate, environmental studies and geology into my area of study. I love being outside, and my goal when I graduate is to do something to help the planet. So something that I am doing this year as a senior particularly is I am writing a thesis, and that sounds a little bit daunting. I know it's still daunting to me at this point. I'm in it. But yeah, so my thesis is basically focusing on an area of study that I'm not an expert in, and I think that's kind of what geology professors have kind of geared towards is, you're not, if you're writing a thesis, you don't have to be an expert in what you're writing in before you start. The process of the thesis is kind of learning as you go. So I'm writing about something to do with remote sensing and satellite imagery to model tectonic uplift in the Adirondack Mountains, which are a couple 100 miles west of Middlebury right now. And so I've been really excited to delve into this project with my advisor, and who's really, taught me a lot going through the process, albeit it's still early. But yeah, so I think that writing a thesis, particularly at Middlebury, and something so interdisciplinary is just a really great opportunity to incorporate things you might learn in a classroom setting and find out how they can have like real life applications, which I think is really a great bridge between, you know, just different avenues of learning that's offered at Middlebury. So yeah.
Awesome. Thank you all so much for sharing all of your wonderful stories. We have a lot of questions coming in from our audience, so we're gonna transition over, but before that, I wanna make sure that our audience has the contact information of all of these wonderful panelists who are here with us today. And so here it is. Thank you again all so much for being here. We hope that we can get to answer as many questions as possible in these next couple of minutes, and I'll leave this up for a second.